In a previous lesson, we learned how to solve compound inequalities and just regular inequalities. Now, in this lesson, we are going to solve absolute value equations and absolute value inequalities. And so we're going to have to rely on some of the information we learned in that previous lesson with inequalities. Okay, the first thing about an absolute value equation, and now an equation is going to have an equal to sign versus an inequality, is that we're actually going to have two values. Because what we have inside the absolute value, if it's a negative number, it will come out positive. Such in this case we have down here, we have a positive 6. And so if that, when that comes out, that will be, the answer will be a positive 6. But we also see that if we have a negative 6 inside the absolute value signs, it will also come out as 6. So therefore, all absolute values are going to have two values. Another way to look at this is, let's consider that I have this equation. I have the absolute value of x is equal to 2. So what I could have is, let's say that what's inside of the absolute value, whatever it is, in this case it's an x, if that's a positive value, then the x will be equal to 2. If whatever is inside the absolute value is a negative, well then when it comes out it would also be equal to 2. So I would say a negative of what's ever inside the absolute value would also come out and equal to 2. So let's see how that works when I'm actually solving an absolute value equation. So what I have here is I have the absolute value of x plus 4 is equal to 2. So if whatever is inside the absolute value is positive, if this x plus 4, whatever it evaluates to, is positive, then that would equal to 12. So we could write x plus 4. If it's positive, then x plus 4 is equal to 12. Okay? If whatever is inside the absolute value, the x plus 4, whatever it comes out to be, is a negative value, it will also be equal to 12. So I can write that this way, that a negative of what's ever inside the absolute value, x plus 4, that would also equal to 12. So what I have here is I have two separate equations. I have this one that says x plus 4 is equal to 12, and I have the one that says a negative of x plus 4 is equal to 12, and I'm going to solve both of those. So for this one, I simply subtract 4 from both sides, and I have x is equal to 8. That would be one of my solutions. For the other solution, what I would do is I would get rid of this negative by dividing both sides by a negative 1. That would put the negative on the 12, so I would have x plus 4 is equal to a negative 12. Now I would subtract 4 from both sides, and I would have x is equal to 16. So that's my other solution. Okay, so let's try another example. So here's an example where I have the absolute value of 4 minus 8n plus 3 is equal to 15. Okay, so the first thing I want to do is I want to isolate the whole absolute value piece. So the only thing I want on this side of the equation is the absolute value. So I'm going to subtract 3 from both sides. And that leaves me with the absolute value of 4 minus 8n is equal to 12. Okay, so now what I'm going to do is, for one of the solutions, if I say to myself, okay, if whatever it is, the 4 minus 8n is positive, that's going to equal to 12. So I can say 4 minus 8n is equal to 12. I also know if what's ever in the absolute value turns out to be negative, it will also be equal to 12. So I'm going to write the second part of it would be, okay, if 4 minus 8n, the negative of that would also be equal to 12. And let's solve both sides now. So what I can do over here is I'm going to subtract 4. And I'll have a negative 8n is equal to 8. Now let's divide by a negative 8. And I would have n is equal to a negative 1. There's one of my solutions. For the other side, I'm going to get rid of this negative, dividing both sides by a negative 1. That would give me 4 minus 8n is equal to a negative 12. Now let's subtract 4 from both sides. That would give me a negative 8n is equal to a negative 16. Now let's divide by a negative 8. And I would have n is equal to 2. So these are both my solutions for that equation. Okay, let's try another example. So here I have a negative 3 minus 2v in absolute value minus 5 is a negative 4. Now what I want to do is I want to get the absolute value piece all by itself, so I'm going to isolate this piece right here by moving the 5 to the other side. So let's add 5. And that's going to give me a minus 3 minus 2v in absolute value is equal to 1. Okay, so now I'm going to try to figure out what the two solutions for the absolute value are. So one of the solutions is just going to be whatever is in there is positive. I'll have a minus 3 minus 2v is equal to 1. And for the other piece, I will have a negative of a negative 3 minus 2v is also equal to 1. So let's go ahead and solve the piece that's on the left. So I'm going to add 3 to both sides. That'll give me a negative 2v is equal to 4. Divide both sides by a negative 2, and I would have v is equal to a negative 2. For the other piece, I'm going to get the negative to the other side, and maybe you can see that that's the first step we're always going to do on the side where we set what's in the absolute value is equal to a negative value. Well, basically, we're just going to move the negative to the other side. So that would give us a negative 3 minus 2v is equal to a negative 1. So if we take a look, we've got negative 3 minus 2v equal to 1 on this side. On the other side, we have a negative 3 minus 2v is equal to a negative 1. So let's go ahead and add 3 to both sides. Gives me a negative 2v is equal to 2. Dividing by a negative 2 gives me v is equal to a negative 1. There are my two solutions. Okay, now here's a couple special cases we have to watch for. Now, one of the first things would be that we would want to go ahead and just start solving this. But let's hold off on that for just a second and take a close look at it. Okay, so like I said, we would be tempted to go ahead and start setting this problem up. But if we pause for a minute, we know that what's ever inside of the absolute value always comes out to be a positive number. Well, once I have the absolute value isolated, it needs to be positive coming out. Well, look what I have here. I have a negative 5. So there's no value that I can have for x or that's going to make whatever's inside that absolute value come out to be this negative 5. So in this case, it's going to be no solution. So we always have to look at our equations to make sure that there's no negative on the other side. Let's take a look at this one. Now this one looks like it's okay because we have an absolute value equal to 4. But my first step is going to be to isolate this absolute value portion. So I'm going to divide this whole thing by a negative 3. And I'm going to divide the other side by a negative 3. What that's going to give me, that'll give me x plus 3 is equal to a negative 4/3. Well, now that I have the absolute value isolated, that means that whatever comes out of there is going to have to be equal to a negative 4/3. It can't be a negative number coming out. So once again, this is going to be a no solution type of problem. Okay, now we're going to move on to absolute value inequalities. So instead of having an equal to sign, these are going to have less thans and greater than signs in there. Like before, when we dealt with inequalities, we're going to solve them just like they had an equal to sign, but we're going to keep in mind that when we divide or multiply by a negative number, we're going to have to switch the inequality sign to go the other direction. Now, one other thing we're going to also need to know is if we have a less than or equal to after I get the absolute value isolated, then that's going to transform into an and compound inequality. If I have a greater than are greater than or equal to, then that's going to create an OR inequality. Once I create these inequalities, the absolute values are gone. So we don't put those back in there once I create the inequality problem. So let's see an example of this. So for this example, I have 9b plus 4 is less than 59. So what we said is we are going, just like with the equal to sign, we're going to set up one of the problems. It's going to be what's ever inside of there, coming out positive. 9b plus 4 is less than 59. All right, now the absolute value is already isolated. There's no negatives outside, nothing is added or subtracted to it, so it's already isolated. So I can take a look at my inequality sign, and I can see that that's a less than. So this is going to form an and. And for the other side, remember, whatever's in the absolute value can be negative and also create this 59. So I'm going to say a negative of 9b plus 4 is less than 59. So let's go ahead and work on both sides. So for the left side, I'm going to subtract 4. I have 9b is less than 55. Now I'm going to divide by 9. So I have b is less than 55/9. I do not change the direction of the inequality because I didn't divide or multiply by a negative. Now let's do the other side. Remember, this is an and, so the and's going to carry on down. The first thing I'm going to do is get this negative off of this side. So if I divide both sides by a -1, this 9b plus 4 will become positive. But when I divide by a -1, this is what's going to happen. I'll have 9b plus 4, but when I divide by a -1, the inequality will switch, and of course, the negative will move to the other side. Now then I'm going to subtract 4 from both sides. So I have 9b is greater than, if I subtract 4 from 59, I get a -63. Divide by 9. And I have b is greater than a -7. And remember, these were ands because of the direction of that inequality after I got the absolute values isolated. So if I wanted to plot these, b is greater than a -7. Well, I don't have quite enough places going out here, so let's go ahead and just put an open dot, what would look like out here, to -7, and b is greater than that. And on the other side, I have b is less than 55/9. And so since 9 times 5, 6 times 9 is 54, this is going to be slightly greater than 6. I would have another line coming out around 6 going this way. And they're both, none of them have equal to signs. So it's an and, so it's the intersection of the two. So my end result would be an open dot somewhere here at a -7, going all the way up to a value that's just slightly greater than 6. And that would be the answer. All right, let's look at this example. Well, the first thing I'm going to need to do on this is I need to isolate the absolute value. So the first thing I'm going to do is divide both sides of this by a -8. Now when I do that, I'm dividing by a negative number. The direction of my inequality is going to switch. So this problem will become 4x minus 2 is greater than a -80 divided by -8 is 10. So now I have the absolute value isolated. I can start solving this. So one of my solutions is simply going to be, when it comes out positive, 4x minus 2 is greater than 10. And the other will be when it's negative, so negative of 4x minus 2 is greater than 10. And look at the direction of the inequality here after the inequality is isolated, so there's nothing added or subtracted to it. It's a greater than sign, so this is going to be an OR. Okay, let's go ahead and finish this. So on the left-hand side, I'm going to add 2 to both sides. It gives me 4x is greater than 12, which would be x is greater than 3. Okay, now this is an OR. So the other side, the first thing I'm going to do is divide both sides by a negative 1. That's going to put the negative on the 10 and flip the direction of the inequality sign. So this would be 4x minus 2 is less than a negative 10. Now let's go ahead and continue solving this. So I would add 2 to both sides. That would be 4x. If I add 2 to this side and add 2 to the other side, I'm going to get is less than a negative 8. Now I'm going to divide both sides by 4. And I get x is less than a negative 2. And of course over here I still have the x is greater than 3. And it's an OR. So x is greater than 3. If I look at my number line, here's 1, 2, 3. It doesn't have an equal to in it, so it's going to be an open dot. Here's where x is greater than 3. That would be an open dot going out to the right. And x is less than a negative 2. Here's negative 1, negative 2. Here's all the values where x is less than a negative 2. Now it's an OR, so it's the combination of both. So my final graph would look like this. Okay, let's do one more example, and this one has a lot of stuff going on. The first thing I have to do, again, is to isolate the absolute value. So the first thing I want to do is I want to get this 8 to the other side. So I would subtract 8. And that would give me a negative 8x plus 2 is greater than a negative 18. Now notice I did not divide or multiply by a negative number, so I did not switch the absolute value. I subtracted. That doesn't switch the direction, sorry, that doesn't switch the direction of the inequality sign. But now right here, I'm going to get this negative to the other side. So if I divide this side by negative 1, and this side by negative 1, that's going to move the negative to the right-hand side. But because I'm dividing by a negative 1, that inequality sign is going to flip. So what I would end up with is the absolute value of a negative 8x plus 2 is less than 18. Now that I have the absolute value isolated, I'm ready to set the problem up. So one of the solutions will be the positive portion that comes out. That would be a negative 8x plus 2 is less than 18. And notice the direction of the inequality. This is going to be an and. And the other part would be if I have a negative of a negative 8x plus 2, that would also have to be less than 18. Okay, so let's work on the left-hand side. The first thing I'm going to do is subtract 2 from both sides. So I have a negative 8x. If I subtract 2 from the left-hand side, I get rid of the 2, and if I subtract 2 from this side, the right-hand side, I get is less than 16. Now I'm going to divide both sides by a negative 8. That will flip the direction of the inequality, so I will have x is greater than a negative 2. Forget this is an and. Now let's work on the other side. The first thing is to get the negative off the left-hand side. So if I divide the left-hand side and this right-hand side by a negative number, what I'm going to have left is a negative 8x plus 2. The inequality will flip and I'll have a negative 18. Okay. Let's subtract a negative 2 from both sides. So I have a minus 8x is greater than a negative 20. Now let's divide both sides by a negative 8. That will change the direction of the inequality. So I will have x is less than 20 all over 8. And let's go ahead and carry the other side down. And of course I can simplify the 20 over 8. So x is less than 5/2. So that's an and. Let's go ahead and plot it. So x is greater than a negative 2. So that would be an open dot. X is less than 5/2. Well, 5/2 is 2.5. So I would also have an open dot where x is less than 2.5 going out to the left. And an and is the intersection of the two. So my final graph will look like that. And that's it for absolute values, solving absolute value equations and inequalities.